In this lesson, we're going to discuss simplifying square roots. In order to simplify a square root, when we don't have a perfect square radicand, meaning that I don't have a number underneath the square root that is a perfect square, such as 25 or 49, we can try to simplify the square root by first identifying the largest perfect square factor, so the largest perfect square that's going to divide evenly into the radicand, and then use the multiplication property to simplify. The multiplication property is that when I have a radical that has a product underneath it, we could separate it into the product of the square roots. So when we go to simplify this first square root, it's going to end up being my perfect square factor underneath. And then the second square root, it's just going to be whatever's left over. So let's take a look at the square root of 27. You may want to have a list of all the perfect squares handy for when we first start doing these problems. As you see more and more, you just kind of notice the perfect square factors automatically. It gets easier as we do more. So here I have the square root of 27. The largest number that's going to divide evenly into 27 from this list here is going to be 9. So I'm going to set this up as the square root of 9 times 3, since 9 times 3 is 27. I can use my multiplication property to pull out that square root of 9, to factor it out, so that we could say the square root of 9 is 3, and I have a leftover square root of 3. This is now a completely simplified radical, so it's 3 times the square root of 3, the square root of 32. So again, I look at my list and I say, all right, which number is going to divide evenly into 32? Well, that's going to be 16. So I have the square root of 16 times 2, which is the square root of 16 times the square root of 2, for the square root of 2. Okay, we have the square root of 20x. Whenever I have variables, I just separate them from the numbers. So the square root of 20 and the square root of x. Okay, the square root of 20, let's start with that. The largest perfect square that's going to divide evenly into 20 is going to be 4. So I have the square root of 4 times the square root of 5, which is 2 the square root of 5. Now let's look at the square root of x. It's really the same idea as we were doing before. We're trying to find the largest perfect square that goes into x. Well, there is no perfect square for x because it's just x all by itself. So that can't be simplified any further. So that x is going to go back under where the 5 is. So the square root of 20x simplifies into 2 times the square root of 5x. Okay, now let's look at the square root of 72x squared. So if you remember, the square root and squared are inverses of each other. So they're going to undo the operation. X squared is a perfect square because it's something that is squared. So the square root and the square cancel, and I'm left with just x. Now let's look at the square root of 72, that portion of it. (36) times 2, which is 6 the square root of 2. Okay, let's put this answer together. I have 6 on the outside, I have x on the outside, and a square root of 2 left over. Okay, the square root of 49x squared y to the 5th. Again, I treat everything separate. The square root of 49, the square root of x squared, the square root of y to the 5th. Square root of 49, that's nice and easy, that's just 7. Square root of x squared we just talked about. That's just x. Now let's take a look at the square root of y to the fifth. Now let's look at the square root of y to the fifth. When I have variables, what we want to do is write them so that they are written as perfect squares. When I have an odd exponent, that adds a little bit of difficulty to the problem, but not much. What we have to remember is that when I have an odd exponent, we're going to rewrite it by pulling out one of those y's. So I have y to the fourth times y to the first. Because remember our rules of exponents, if I have the same base, I could add the exponents. So it's kind of like we're subtracting it out. Okay, the reason why we do this is so that I can simplify that exponent with the square root. Remember what we have here. Square root and square cancel out. So I need to think of how can I write y so that when I have it to the second power, it cancels out with the square root. Well, y would have to be squared. Again, back to those rules of exponents. 2 times 2 is going to multiply to 4. We multiply those exponents together. So the squared cancels out with this, and I'm left with a y squared that's now on the outside. Okay, I have a leftover y. So my answer is 7x y squared, the square root of y. If you remember back to the first video, I talked about how we treat square roots as we would exponents. And the reason why is because radicals are really just another way of writing an exponent. It's actually a fractional exponent. So if I have a square root, it's treated as the 1/2 power. So if I had the square root of x squared as I did before, it's really x squared to the 1/2 power. Remember our rules of exponents. When I have a power raised to a power, I multiply them together. That gives me x, same as what I have here. With our y's in the odd exponent, we start off the same way. We say I have y to the fourth and the y pulled out next to it. Y to the fourth to the 1/2 is y squared. 4 times 1/2 is 2. There's my y squared. My leftover y stays under the square root. So 2 different ways of thinking of the same concept. You just kind of have to figure out which one makes more sense to you and go with that method. Let's try this one. 48x cubed y to the 8th. So I have the square root of 48, the square root of x cubed, the square root of y to the 8th. So 48 is the square root of 16 times 3, which is 4 the square root of 3. The square root of x cubed, square root of x squared times x, because we always pull off one of those x's as our remainder. The square root of x squared is x. I have a leftover square root of x. Square root of y to the 8th. Again, if we think about it as a 1/2 power, y to the 8th to the 1/2 is y to the 4th. So we have 4x y to the 4th times the square root of 3x.